Alright, welcome. In this video, we're going to be practicing for test 6 in AP Pre-Cal. And so it's a test over unit circle trig, radians, sine, cosine, tangent, secant, cosecant, cotangent, all that stuff. And so like always, we're going to be practicing on a set of problems that I got from the personal progress check. And they're great, but the best way to review is going to be going back and looking at the quizzes and the notes. Okay, so first one, table gives characteristics of a trigonometric function f for for selected values of theta. Which of the following could define f of theta? This one might be a bit of a stretch for what we were doing, because we're not really talking about f of x equals sine x yet, but I thought that if we had thought about this in terms of the circle, that we could solve it. So I'm going to bring in a unit circle. All right, and so they're saying that f of theta, when theta is between pi and 3 pi over 2. So I'm just going to remind you, pi is over here at the far left edge of the circle, right there. And then 3 pi over 2 is down here at the bottom of the circle. And then they're also mentioning 2 pi, so I might label that as 2 pi over there. All right, so we're looking for the type of function that is negative over here and positive over there. Okay. And so if we, I might just draw a couple of reference triangles now that I think about it, and label which side is going to be positive and which side is going to be negative. Okay, maybe on this one, I'll go down here so it looks a little different. I want you to think that these are just the same triangle. These are just some arbitrary triangle in the third and fourth quadrants. Okay, but it's a reference triangle because they have one vertex at the origin, another vertex on the x-axis, and then the third vertex on this unit circle. Okay, so for these reference triangles, the hypotenuse is always 1. That's pretty much all I know. I'm going to say that over here for the fourth quadrant, this one's positive and that one's negative. And in the third quadrant, they're both negative. Okay. So the type of function that would be positive in the fourth quadrant, and we talked about this, and if you remember all my students take calculus or at least college algebra, well then you might know it's cosine. Okay, but if you think about the reference angle and think about what's going to be positive, it's going to be adjacent and hypotenuse. So that's cosine. Cosine of theta is positive in the fourth quadrant. Okay, so that's my hypothesis, because all the rest of them, besides secant, are going to be negative. If you think about opposite over hypotenuse, opposite over adjacent. These things are going to be negative because they're negative and positive, and they're using that vertical side. All right, so if I think about over here, does the cosine theta, is it negative in the third quadrant? Yes, it is. I've got an adjacent, which is negative, and a hypotenuse, which is 1. Okay, so I'm going to say that this is cosine theta only. And then what I might also add is that sine is negative on both of those intervals. Sine, because we're down there below the x-axis, our vertical leg of our triangle is going to be negative. The displacement from the x-axis to the point on the unit circle, that's going to be negative. Okay, that's what sine is. It's the vertical displacement from the x-axis on the unit circle. Okay, now number 2. The figure shows a circle in the xy plane centered at the origin, an angle of measure theta in standard position, and the intersection point of the terminal ray. What's the value of sine theta? Oh, yeah, we love these. Okay, so they already drew the diagram for us. So, we found the spot on the unit circle. Step 2 is draw a reference triangle. So we can do that. And they even told us, no, they did not tell us what the hypotenuse of the triangle was. So the coordinates are -3 and -4. Okay, so we'll go and we'll find the radius of the circle, or the hypotenuse of the triangle. It's going to be r. So r squared is going to equal -3 squared plus -4 squared, meaning that r squared is 25. And because we're interested in a positive radius of the circle, we're going to say r is equal to +5. Okay. Now we will eventually be interested in where r goes negative, but that'll be more of a discussion of polar coordinates, and we're just not there yet. We need a little time. You need to be older, right? I'll wait till you're older and I'll tell you about that. So, what I'll say is that we'll use this reference angle right there, and if we want sine theta, it's going to be opposite over hypotenuse. So opposite that angle is -4, hypotenuse was 5, so it's going to be -4/5. It's also really the true definition, or at least that they gave in the AP Pre-Cal course description, of sine theta is the ratio of the vertical displacement from the x-axis, that would be -4, to the hypotenuse of the triangle, or the radius of the circle. So that would be -4 to 5. And that's going to be answer choice B. All right, this next problem is talking about terminal ray of an angle in standard position intersecting the unit circle at point P. Okay, now something that I obviously did not emphasize well enough in my own sections of AP Pre-Cal was when they say the unit circle, they are talking about the circle that's centered at the origin in the XY plane and has radius 1. Okay, there's only one the unit circle. So I just wanted to remind you of that, but before it was too late. So which of the following is true as the angle measure increases from 0 to pi? Cosine of the angle. I'm going to just draw myself a little circle. Okay, I'm going to only draw the upper half of the circle because out here is 0 and over there is pi. Right? It's the first half of the circle. All right, so cosine of theta and the terminal ray intersects at point P. All right, I think I'm trying to decide what's going to be the best way to explain this one. I think what I'm going to do is remind you about one of our more recent facts about cosine of 0, cosine of pi, and also maybe I'll just do cosine of pi over 2 while I'm at it. Yeah, I think that's going to be the way for us to go. All right, I'm going to label the coordinates of these points. These are kind of the extreme values, so we just go off of coordinates, right? Because there's no real triangle to show there. And you have two sides with length 1 and a side with length 0, which y'all would tell me is not a triangle. And you'd probably be right. So what was I thinking here? Okay, yeah, the coordinates of that first pointer were x is 1 and y is 0, because it's the unit circle, 1 unit away from the origin at all times. And that'll be 0 and 1. Over here, this is going to be the place where x is negative 1 and y is 0. All right, and cosine is the x coordinate. So what I'm saying is that it goes from 1 as theta increases, or, as theta increases, then P moves right to left. Our x coordinate is going to be decreasing. So it's going to go from 1 to 0 to negative 1. All right, so cosine of the angle decreases. Okay, and so I'm going to use that to eliminate, answer choice A, because it says decreases then increases. Okay, and becoming more negative, that's still decreasing. Okay, it's been a while since we've talked about increase and decrease, and that's something we're going to talk about kind of at length in the next unit. But for now, I'm just going to tell you, okay, it's going from 1 to negative 1 is decreasing the whole time, as long as we're not like going down and then going up and then we're decreasing to negative 1. Okay, even though it feels like going from 0 to negative 1 is getting bigger, in a sense it is, it's still decreasing. All right, the cosine of the angle decreases because the horizontal displacement of P, okay, I'll parse through that in a second. Increases then decreases, that's out as well. All right, so because I'm saying the cosine of the angle is only decreasing. Horizontal displacement from the y-axis decreases over the entire interval. That sounds right, so what's the issue with D? Vertical displacement. Vertical displacement, that's sine theta. Okay, so we're talking about cosine theta, so that's going to be answer choice B. All right. Now, number 4 is going to require a graphing calculator. And, you're not going to be allowed a graphing calculator on the test. But I thought this was a really nice problem, and we're going to a place where eventually we're going to need a calculator. So I'm going to show you how to do this one. All right, so I got the calculator. We're saying in the xy plane, the terminal ray of theta in standard position intersects the unit circle at point P. The x-coordinate of P is 2 times the y-coordinate of P. And theta is between 0 and pi over 2. What's the value of theta? Yeah, I remember I really liked this one. I'm going to draw a diagram. All right, it's said to go 0 to pi over 2, so I'm going to do exactly that. I'm going to say, all right, over here is theta equals 0, up here is theta equals pi over 2, and we're kind of rotating upwards. Oh, no, this is not the one where theta is changing. Okay, pardon me, that was a different question. Terminal ray of an angle of measure theta in standard position intersects unit circle at point P. X coordinate of P is 2 times the y coordinate of point P. All right, so I'm going to draw us a terminal ray, and I think I want it to be kind of down there. Yeah, it looks believable. And then I'll go over here and draw the initial ray. So this, arc right here, that represents theta. And the unit circle, okay, so I don't think that actually matters. But who knows, maybe it does. Go in, finish out my reference triangle. And then I'll say, okay, wait, this is also part of my reference triangle. And that's probably not going to snap too, but it'll be all right. Okay, the x-coordinate of P is 2 times the y-coordinate of P. I think what I'm going to say is, all right, we've got a y-coordinate. And then the x-coordinate is 2 times that. So I'm just going to call it 2y and y. Okay, that means that the horizontal leg of this triangle is going to be the 2y, and the vertical leg will be positive y. All right, so I got to figure out what's the value of theta. Well, you could do Pythagorean theorem and figure out what it's going to be. I think it's going to be square root of 5y, with the y not inside the square root. But I think there's a better way. I think what I'm going to point out is that, okay, I've got an opposite, I've got an adjacent, I can set up a tangent relationship. Yeah, I remember thinking there wasn't much inverse trig on here, and I definitely wanted you to be, aware of that. So tangent is opposite over adjacent. Oh, and y over 2y, that's something I can simplify. I'm just going to be behind the calculator. All right, for any y that's not equal to 0, that's going to be a half. And so I'm going to say tangent of theta equals 1/2. Therefore, I could take the inverse tangent of both sides. Okay, and I'm going to take inverse tangent of a half. Now, it's going to be really important that my calculator is in radian mode. I don't think you can see, actually I think if I clicked over here, yeah, then you'll be able to see. I need to make sure I'm in radian mode, okay, because degree mode is going to give you a number of degrees, and none of these answer choices are an appropriate number of degrees that's going to give you tangent of that number of degrees equals a half. So, and I am not saying that a person could not just go and plug in tangent of all the answer choices and see which one comes back a half. That's an option you've got. That's probably what I'll do at the end. But what I'm going to do is I'm going to go and compute inverse tangent of a half, press go, and then get 0.464. So that's answer choice A. So I'm feeling pretty good about that. But what I'll do, just to emphasize, is that I'll take tangent of 0.464 radians, and I should get something really close to a half. Yeah, there we go, 0.500. Okay, I think that's all I got to say about this problem. All right, the next one has got two angles in standard position, alpha and beta. Alpha and beta are both between pi over 2 and pi, so that means second quadrant. I'll draw that for you. All right, I'll draw myself a quarter circle, and hopefully, yep, that worked out. And then I'm going to label pi over 2 and pi. Okay, which of the following is true about tangent alpha and tangent beta? I think I should probably draw in some reference triangles. All right, so alpha is less than beta in terms of radian measures, how far we've rotated counterclockwise from the positive x-axis. So alpha happens first as I'm rotating counterclockwise. So I'm just going to draw a terminal ray here. And then I'm going to have a terminal ray over here. I'm going to say this one over here corresponds to angle alpha, and that one's going to correspond to angle beta. And, well, I think if we consider the coordinates of these points, at both of these points, I'm going to have x negative and y positive. Tangent being opposite over adjacent, or the y coordinate on the unit circle divided by the x coordinate on the unit circle, there's going to be negative, because I'm going to have y coordinate is positive, divided by x coordinate, which is negative. Positive over negative, it's negative. Okay, so tangent of alpha and tangent of beta are both greater than 0. Unfortunately, I don't think that's not accurate. They're both less than 0. Okay, tangent of alpha is less than -1. It depends on where on the circle we are. Okay, now this one's tougher than I give it credit for when I first looked at it. I think it's gonna be tangent alpha equals tangent beta. That's not realistic, right? They're different angles, so they're gonna have a different tangent. Okay, you can't have the same tangent if you're off like by all the way across the circle. Have the same tangent. Now let's think about why that's true. But for this one, if they're in the same quadrant, they can't have the same tangent. So I gotta think I'm eliminating A as well. And why is that? I see what it is. Okay, I'm gonna pause for a second and think about how I'm gonna explain this. All right, now this is what I'm about to do is what I think y'all would do. Okay, it's not what I would do, but what I was gonna do is gonna be, I think, beyond the scope of AP Pre-Cal. I think y'all would look at this and be like, oh, well, maybe alpha could be 2 pi over 3 and beta could be 5 pi over 6 or 3 pi over 4 or something just farther along. And just draw actual reference triangles and see what's gonna happen. Okay, I think that'll be a valid way for us to proceed. So I'm just going to draw in some reference triangles, always back to the x-axis, but I think y'all are good on that now. Whoops. Okay, there we go. Perfect. It's two different reference triangles, but I think, yeah, I'm gonna break them out and show you a reference triangle for alpha, a reference triangle for beta, take tangent of both of them, and then I'll be able to show you what I'm saying. All right, so for the reference triangle for angle alpha, that's going to be a tall one. Okay, that's a 60-degree reference angle, so the long side is root 3 over 2, the short leg is a half, and the hypotenuse is 1. Okay, I think about what's going to be positive and what's going to be negative. I already said x is going to be negative, the horizontal leg is going to be negative. Okay, so tangent of alpha, yeah, you still have plenty of room. Tangent of alpha is going to equal root 3 over 2 divided by negative 1/2. So that's negative square root of 3. Because dividing by a half is like multiplying by 2. All right, then I'm going to do the same thing for beta. Okay, for angle beta, I'm going to draw it. It's going to be a 30, 60, 90 triangle. Reference angle is 30 degrees. So the short leg is a half, the longer leg is root 3 over 2, and the hypotenuse is 1. I check to see what should be negative here. The horizontal leg, because I'm in the second quadrant. Okay, so I got negative root 3 over 2. And then over here, tangent of beta is equal to 1/2 over negative square root of 3 over 2. So I'm going to say that once I end up doing that, you're going to end up with negative 1 over the square root of 3. I actually like this. I think I'm going to leave it unsimplified. I think it's actually, no, I'm not. Negative 1 over the square root of 3 to me is clearly a less than 1 number, but I don't know if that's as obvious to y'all. So I'm going to rationalize the denominator here. And then that's more obvious to you. All right, so if I've got tangent alpha equals negative square root of 3, and tangent beta equals negative root 3 over 3, I'm going to draw in a number line. I don't know how hard y'all are going to think this problem is, and I don't want anybody to be needlessly confused, so I'm going to go through all the details. So I'm going to put 0 here on my number line. Okay, maybe I'll put negative 3 over here. Okay, now first of all, I know that the square root of 3 is less than 3. So the negative square root of 3 will be closer to 0 than negative 3. And this is not going to be drawn to scale. I'm just warning you. This is going to be the negative square root of 3. And then negative root 3 divided by 3, well, if I'm dividing it by 3, I'm going to get closer to 0. Y'all know that dividing a number by 3 makes it smaller. So we're going to go over here and say that's negative root 3 over 3. But negative root 3 was tangent alpha. Negative root 3 over 3 was tangent beta. So I'm showing you tangent alpha is less than tangent beta, okay? Without getting into is tangent increasing or decreasing between pi over 2 and pi. Yeah, even thinking about that, I confused myself, so that's not going to be necessary. I just showed you that tangent alpha is necessarily less than tangent beta. Also, tangent beta, that's less than 1, I think, or pardon me, definitely less than 1 because it's negative, but it's between 0 and negative 1 is what I'm saying. Because if you think about this number right here, tangent beta, negative 1 over the square root of 3. Square root of 3 is a bigger than 1 number. If I take 1 over something that's bigger than 1, I'm going to have what y'all call a fraction, something between 0 and, in this case, negative 1. And so I know that tangent beta less than negative 1, that's not necessarily true. Could be true, right? If both of the angles were kind of up near pi over 2, I believe that could be true, but is not a must be true. I would change the wording of the question to must be true, but that's just me. All right, next we've got a figure showing the terminal ray of an angle in standard position intersecting the unit circle at point P. PQ is perpendicular to the x-axis. Yeah, we like this question. I wish I had seen this one before I ordered the test copies because I would definitely put this one on there. Triangles formed by the points PQ and O, the origin. A gives the area of triangle A of theta based on the measure of angle theta in radians. So we're going to basically allow theta to increase. I might just go ahead and label theta. Oh, not in blue highlighter, definitely in blue pen. Okay, that was theta right there. You couldn't really see it, but that's more like it. And so as theta increases, we're really only interested in the value of the area of the triangle when theta is pi over 3. And they helpfully drew a diagram that you could work off of that one. That's probably 60 degrees. That's pi over 3. Okay. I would probably not have drawn you that diagram, but that's just me. So I'm going to draw the reference triangle. Maybe I'll kind of do a replica here. Okay, initial ray, terminal ray at 60 degrees, reference triangle, maybe that's where the hypotenuse will be 1, the other leg of the reference triangle, and then I will indicate that's a right triangle. Remind you that's theta equals pi over 3. That's a 60-degree angle. The short leg is a half. The long leg, I think I usually label that in red. Short leg is a half. Long leg is root 3 over 2. Hypotenuse is 1. Okay, so I'm over here in the first quadrant. Pi over 3 is very early on. Everything's going to be positive. Everything's positive in the first quadrant. So I don't need to worry about anything being negative. And the area of the triangle, wait, let me make sure, the unit circle. Okay, so because of that, I know the hypotenuse is 1. And this also would have been a really good question to ask with a circle that wasn't radius 1. But I'm over here, and I'm going to say, all right, area of theta is equal to 1/2 base times height. Okay, the base is a half. The height is root 3 over 2. 1/2 times root 3 divided by 2. And I'm going to multiply these fractions. I'm going to multiply straight across. 1 times square root of 3 is square root of 3. 2 times 2 times 2, that's 8. And that's going to be answer choice A. Right. So I have got here, this is a very standard question for what we've been doing lately. Here's an angle in standard position, A. A is 2 pi over 3. What's the x-coordinate of P? It's intersecting a circle of radius 3. So find the spot on the unit circle. They already did it for us, right? We're there, we're happy. We're going to draw a reference triangle. We're going to label the reference triangle. Okay, hypotenuse is, oh yeah, okay. No, I'm gonna label a separate, a template triangle first, and then I'm gonna scale it up and figure out what it's supposed to be. So, draw a template triangle. All right, so I've got my template triangle, and I've labeled the sides, and now I need to stop and take a second and think which of these is going to be negative. In the second quadrant, place where x is negative and y is positive, so the horizontal leg will be negative, and the vertical leg will be positive. Now I think to myself, what did I multiply the blue triangle by to get the red triangle? Okay. Red triangle has a hypotenuse of 3, so we can see that. And so I multiplied the blue triangle by 3 to get the red triangle. And so what I'm going to do, I'm going to take the other sides, and I'm going to also multiply those by 3. Okay, so here I'm going to have 3 times negative 1/2, and 3 times square root of 3 divided by 2. And I know it only asks for the x-coordinate of P, but I'm going to give you both of them, right? So over here, the coordinates of P are going to be x is, how far to the left I went along that triangle, so that's negative 3/2. And y is going to be how far up I went from that spot on the x-axis, so that's 3 root 3 over 2. Okay. X-coordinate, negative 3/2. Happy. Let's move on. Yes. We love this one. F of theta equals secant theta. Which of these is also defining f? So which of these is equal to secant theta? Okay, this is one you need to know. Maybe not because I'm going to ask it to you like this on the test, but I could ask you about secant of pi over 4, and you would need to know that in order to find the secant of pi over 4, you need to start with cosine of pi over 4 and then flip the fraction. And it seems like people in my class are really up with secant, cosecant, and cotangent, knowing the reciprocal identities. And I'm glad to see that. because that's going to be important for us. I don't know, maybe not like an overall in our lives, but that's going to come back here and there for the rest of the time you take the math classes. So 1 over cosine theta is here. It's not inverse cosine. Inverse cosine is like arc cosine. I don't really ever like for theta to be the argument, the thing that goes on the inside of inverse trig, because inverse cosine is the type of object that, if you know the cosine, suppose you know that that's 4 and this is 5, which might be 3, you can figure out theta. Theta would be inverse cosine of 4/5. So inverse cosine of a number should give you a theta value. Okay, that's what I'm saying. If you're good with secant as 1 over cosine, good for you. Let's move on. All right, and now we just got some unit circle practice because we need this too. I'd say up to like a third of the questions on this test are kind of like this, just like, here's a trig function, here's a radian input on the unit circle, find the value. Which of these is right? Okay, so we need to be able to do that because I want you to be doing better than just random guessing, right, on these. But I think we're doing pretty good. Based on the work I've observed people doing in my class, it looks like we're making good progress on the unit circle trig. I'm going to reserve judgment until after y'all take the test, but it looks like so far it's going pretty well. So cosine of 0. All right, I'm going to bring in a unit circle or something I can copy paste for all these problems. All right, so always, respecting that 3-step process. First, find the spot on the unit circle. Okay, 0 radians is right here at the far edge, right where we start. Okay, so that's theta equals 0. Step 2 is usually draw a reference triangle. We're not going to be able to draw a reference triangle because, we're on the x-axis, right? Not really anything to draw. So we're going to default to the coordinates of this point. On the unit circle, the coordinates at this point would be x equals 1 and y equals 0. And the cosine of theta is the horizontal displacement from the y-axis, or the x-coordinate, and so that's going to be 1. Okay. Let's see, just paste 1 in here. Yep, you can see that. And, okay, sine of 7 pi over 4. Step 1, find the spot on the unit circle. That's going to require a little bit of work. Now, if you know where 7 pi over 4 is already, and you're like, dude, I don't need to do any work, that's exactly what I'd hoped for you. I'd really hoped that, by this point, you'd be able to just know that 7 pi over 4 is going to be right down here in the bottom right, halfway along. But if you don't see that, if you're not into, like, just memorizing the stuff, think about it. It's almost 2 pi, because 2 pi would be 8 pi over 4. It's just short of 2 pi by pi over 4. So I would go to 2 pi, and then I would go back by pi over 4. So I'm going to draw the angle in the standard position. So it started there on the positive x-axis, or close enough. And then it's going to end at 7 pi over 4, which is almost all the way to 2 pi, just short by that 45 degrees. Okay, that's 7 pi over 4. Or at least this much rotation there. That's 7 pi divided by 4. All right, now I'm going to draw a reference triangle. And draw it vertically, back to the x-axis, always the x-axis. I'll put that one there. It'll indicate that it's a right triangle, and then I'll get to labeling my sides. This is a 45, 45, 90 triangle. I didn't actually label the reference angle, but yeah, I can do that right now. Okay, and for our 45, 45, 90s, on the unit circle, hypotenuse is 1, and both of the legs are root 2 divided by 2. Okay, I'm going to stop and think what needs to be positive, what needs to be negative. In the fourth quadrant, x is positive and y is negative. So go over and do a little bit of that. Okay, sine of 7 pi over 4 is opposite over hypotenuse, so SOHCAHTOA. So it's going to be that negative root 2 over 2 divided by 1, negative root 2 over 2. Okay. Really, my goal is for you to do all of these without drawing a diagram, but of course on video, I'm going to draw a diagram every time, right? Just in case you aren't able to just visualize it, or if you're not there yet. We'll get you there eventually. If you just keep practicing, you'll get it. But if you're not there yet, just keep drawing the diagrams. Nothing wrong with that. Okay, now for secant of 2 pi over 3, I'm going to start by locating the spot on the unit circle. And I do want you to know where 2 pi over 3 is without doing this. But in case you're not sure where it is, 2 pi over 3, 2/3, that's less than 1, right? So how far do I go back from pi? So that's 3 pi over 3 is 1 pi. And I'm going to go back by pi over 3. Okay, so I'll start by drawing my initial ray. And then the terminal ray, okay, pi is over here. So I'm going to go back by pi over 3, and pi over 3 corresponds to a 60-degree angle. So I'm going to come up here. Okay, that'll work for me. I'm going to draw a reference triangle. Okay, and then I'll label the sides. Okay, on the unit circle, hypotenuse is 1. Okay, this is a 30, 60, 90. Okay, I'll just best I can label that's a 60-degree reference angle. And then short leg's a half, long leg is root 3 over 2. Think about what's going to be negative. It's going to be the horizontal leg. And then I'll say secant. Well, first I'm going to need cosine. So I'll start with cosine of 2 pi over 3. So cosine of 2 pi divided by 3, it's going to be adjacent over hypotenuse, negative 1/2. So I'll conclude that secant of 2 pi over 3, that's going to be equal to negative 2 over 1. So that'll just be negative 2. Okay, now we've got 11 pi over 6 here. That's, well, 12 over 6 is 2, so I'm really close to 2 pi. So I'm going to say that this is 2 pi minus a pi over 6. Okay, so I'd go all the way, almost all the way around, okay, just short by 30 degrees, or go all the way around and then go back 30 degrees. Doesn't matter, however you want to look at it. Okay, now I'm going to draw myself a reference triangle by going from the intersection point back to the x-axis. I'll need another leg. I don't know that that was exactly a right angle. I'm going to, might be a little bit of vanity there, but I want this to look good. All right, and then I've got myself a right triangle. This is going to be a 30, 60, 90. Okay, the reference angle will be 30 degrees because it's something over 6. And then I will label the sides. The hypotenuse is 1, the short leg is a half, and the long leg is root 3 divided by 2. Check to see what needs to be negative. In the fourth quadrant, the vertical leg will be negative. And tangent is opposite over adjacent. All right, so it's going to be opposite is negative 1/2. Flip and multiply by adjacent, that's 2 over square root of 3. And so I'm going to get negative 1 over the square root of 3. I'll need to rationalize the denominator. I'll get negative root 3 divided by 3. Okay, as far as sine pi goes, okay, we identify pi on the unit circle. We need to know that's just right there. We're not going to be able to draw a reference triangle, so we'll just default to the coordinates. X is negative 1 and y is 0 over here. Okay, sine is the y coordinate, so I'm going to say sine of pi is equal to 0. Okay, for cosine of 4 pi over 3, 4 pi over 3 is bigger than pi. So that's going to be pi, 3 pi over 3, plus an extra pi divided by 3. All right, so pi would be to the far left edge. I'll draw the initial ray of the angle. Terminal ray, pi over 3 beyond pi, that'll be 60 more degrees. So I'll just go down here. That's probably more than 60, but, you know, makes for a good triangle. I'll draw in my reference triangle. Looks like a good one. Okay, and I'm going to label the sides. Yeah, I feel like there was something I was missing here, but no, I can't think there is. Didn't label the reference angle, but it's 60 degrees. 1, this is the longer leg. I don't think you really need to label the reference angle if you can see which leg is clearly longer. And then there will be a half in the third quadrant. Both legs will be negative. And if I'm taking cosine, that's adjacent over hypotenuse, that's going to be negative 1/2. Okay, for cosecant of 5 pi over 6, you start with the angle. 5, 6 is not all the way to 1. It's less than 1. So 5 pi over 6 is equal to a whole pi. So that's 6 pi over 6 minus a pi over 6. So I would go all the way to the left and then back by pi over 6, so back by 30 degrees. So I'll draw that about here. Okay, now I'll draw a reference triangle. Okay, indicate that it's a right triangle, label the sides. Okay, for 30, 60, 90, once again, hypotenuse is 1, short leg's a half, long leg is root 3 divided by 2. Okay, Over here in the third quadrant, so I need to think about what's going to be negative. That will be the x-coordinate, the horizontal leg. All right, cosecant, well, I need to start with sine. Okay, so we'll start by computing sine. Sine of 5 pi divided by 6 is going to be opposite over hypotenuse equals a half. And since cosecant is the reciprocal of sine, cosecant is going to be 2 divided by 1. And so I'll just say that cosecant is equal to 2. All right, this has been a really good set of unit circle problems because it's been like a different spot on the unit circle every time. I really like this one. Okay, 5/3. That's bigger than 1. Okay, and the question is it closer to 2 or is it closer to 1? Well, 1 is 3/3 and 2 is 6/3. So I think 5 is going to be closer, or 5/3 is going to be closer to 2 than it is to 1. So I'm going to go from 2 pi. So I'm going to say 5 pi over 3 equals 2 pi minus a pi over 3. All right, so I will draw the initial ray of the angle. Draw the terminal ray. 5 pi over 3 is all the way down here. Back by 60 degrees from 2 pi, you could look at it. Maybe we did already. No, I think it was 7 pi over 4 that we already did. So this is a pretty good one. Okay, draw the reference triangle. All right, and then I'm going to label the sides. Hypotenuse is 1, short leg's a half, long leg is √3 divided by 2. All right, what's going to be negative? The vertical leg, because I'm in the fourth quadrant. And then cotangent, I'm going to need, you could do tangent first, but if you know tangent is opposite over adjacent, and cotangent is going to be adjacent over opposite, I think we can just do that. So I'm going to say cotangent of pi over 3 is adjacent is a half. Dividing by a fraction, we're going to multiply by the reciprocal. 2 over the negative square root of 3. That equals negative 1 over the square root of 3. And we've already rationalized this number once in this video, and I'm not going to, waste your time on doing it again. I'm going to tell you that's negative √3 divided by 3. Okay, now I've got cosine of 13 pi over 6. Good. I was hoping that we would go beyond 2 pi or go into the realm of negative angles. Okay, 13 pi over 6. That's bigger than 2 pi. Okay, I know that because 2 pi is 12 pi over 6. So I'm going to look at this as 2 pi plus an extra pi over 6. Okay, so really it's just the same as pi over 6. Right, it's at least the same spot on the unit circle, right? In some ways similar, some ways different. Very different amounts of rotation. Okay. So I'm going to draw myself a reference triangle. Indicate that it's a right triangle, label the sides. Hey, hypotenuse is 1 for 30, 60, 90. The short leg is a half, and the long leg is √3 divided by 2. Okay, over here in the first quadrant, everything's positive. Both legs of the triangle, and the hypotenuse is always positive, at least for this unit circle trig discussion. And so, what was I thinking? Oh, cosine. Okay, adjacent over hypotenuse. √3 over 2 divided by 1. Okay. So if we can just find the spot on the unit circle, oftentimes these ones that are beyond 2 pi are not any more difficult than what we were already used to. And right, tangent of 3 pi over 2. So I'm going to label 3 pi over 2 on the unit circle, and that's when we just got to know where it is. Oh, nice. Okay, this set's got it all. It's going to have one that's undefined also. Really like that. So I'm going to label the coordinates. X is going to equal 0 at that point, and y is going to equal negative 1 because this is a unit circle. And tangent is y over x. So I would be thinking, okay, y divided by x, can't divide by 0. I'm going to say that's undefined or does not exist. All right, it kind of stopped fitting on the screen, so I'm just going to draw my own diagram and copy in the problem. Cotangent of 5 pi over 4. Okay, you need to know where 5 pi over 4 is. That's going to equal pi plus pi over 4, because 1 pi would be 4 pi over 4. So I'm going to go to pi, and then I'm going to go farther by 45 degrees, because that's what pi over 4 is. So we'll go down here, beyond pi by 45 degrees. And I will draw in my reference triangle. label the sides. It's a 45, 45, 90, which feels like it's been a while since I've had one of those. So the hypotenuse is 1, and each of the legs is root 2 over 2. Okay, think about what's going to be negative. In the third quadrant, both legs will be negative. Okay, and cotangent is opposite, or no, pardon me. Tangent is opposite over adjacent. Negative root 2 over 2 divided by negative root 2 over 2. You take a number and you divide it by itself, it's going to be 1. So I'm going to say tangent of 5 pi over 4 equals positive 1. As a result, I know that cotangent of 5 pi over 4, I'm just going to put 1 over that. Okay, 1 over 1. Okay, that's just equal to 1. Okay, and then the other one, I'm just going to take a peek. Sine of negative 3 pi over 2. So I'm taking sine of negative 3 pi divided by 2. All right, now, yeah, okay, good. Probably good that we got a negative angle in here. All right, so negative 3 pi over 2. I hope that you can be like, okay, well, positive 3 pi over 2 went there, almost all the way around the circle, and stopped short by, pi over 2. And so I would hope that you could just like kind of reverse that process and say negative 3 pi over 2 is going to be that one. Okay, but if you didn't feel like that was realistic for you, then what I'm going to do is say find a coterminal angle. Okay, we can always find a coterminal angle by adding 2 pi or subtracting 2 pi or adding some multiple of 2 pi. Any multiple of 2 pi, any integer multiple of 2 pi. So, if you weren't seeing this, I'd tell you to do negative 3 pi over 2. This is a negative number, so to get to the ones I'm used to, which are all positive numbers, I should add 2 pi. Okay, now 2 pi will be 4 pi divided by 2. And so that'll be negative 3 plus 4 is positive 1 pi divided by 2. And, okay, pi over 2, that's up here. Okay. So the sine of negative 3 pi over 2, I'm going to label the coordinates here. X is 0, y is positive 1. All right, so what I'm saying here is sine of negative 3 pi over 2 is going to be equal to the sine of positive pi over 2 because those angles are coterminal, and that's going to be the y coordinate on the unit circle, so that's going to be equal to positive 1. And I think, yeah, that's going to be all the problems we've got for this practice set. Like I said at the beginning, if you are really wanting to see like exactly what's going to be on the test, you should look for those weird problems on the notes and homework and the quizzes, like with very specific wording on them. I didn't just make it up. Look for those. Come see me before school if you need extra support, but like that's going to be all for this video. Thanks for watching.